Okay. All right, let's look at the next one. This question is going to hit a little bit close to home this weekend. You are driving from Houston to Abilene at a constant rate of 70 miles per hour. Abilene is 357 miles away, for reals. Like, for reals it is. How long will it take you to arrive in Abilene? You will never arrive in Abilene. Okay, so what do you think my equation is? Y equals 70x, right? I could say 357 equals 70x, right? But if I do, again, that's that specific equation. We want to write the most general equation we can so we can answer any question they give us. And we always want to get in the practice of doing this, okay? Because remember, as algebra students, we want to be able to answer any question, not just the specific one they asked us, okay? So y equals 70x. X is whatever's after the word per. So hours, so it's number of hours. Now, we want to be specific, okay? We don't want to just say number of hours, because number of hours what? Like number of hours in a tanning bed, number of hours it took me to draw a picture? No, it's the number of hours traveled, okay? Number of hours driving. We want to be very specific, because that way we know exactly what we're putting in for that variable. So what is y going to tell me? Total what? Total miles driven? Okay, total miles driven. I like that. We're going to do another problem that shows you why defining this variable really matters. Okay, so we have total miles driven. So now I understand what's happening here. I understand the ins and outs of my equation. Now I need to think about my data. Okay, because, 70x. Y equals 70x. It says 70 miles per hour. What kind of data do we think we have? You're all so quiet. What do we think we have? Continuous. I agree that we have continuous data because I can measure miles, I can measure hours, and these things are going to happen gradually. It's not like every hour I suddenly teleport 70 hours ahead. Every hour, I'm going to gradually make my way through 70 miles. And the next hour, I gradually make my way through 70 more. So I would agree this is continuous data. Okay, now, what that means is I probably need this card. My domain and range are going to look like in one of three ways. They're either going to look like all real numbers, which almost never do we see a real-world situation that looks like all real numbers. Because, I mean, real-world situations happen in quadrant 1. We don't usually get to go negative. So we don't usually see this. This is not usually something we see in a real-world situation. We may see, like, x is greater than or equal to 5, or y is less than or equal to 7, or something like that, an inequality. And that's what we see when we have a value that looks like that. Now, we might also see one of those between statements, like x is less than, 5 and 15. X is between 5 and 15. And that's what we see when we have a starting point and an ending point. Which one do you think we have here? I think we have a starting and an ending point. I agree, because I'm starting in Houston, I'm ending in Abilene. So that means the miles I drive are going to be between, and the time I drive is going to be between Houston and Abilene. So if I look at my x values, that's my domain, right? If I think about the number of hours I travel, well, first of all, I got to figure out how long it's going to take me to get to Abilene, okay? So I'm going to put that equation that we made in there. Turn that so that it's actually visible. So 70x. And then I'm going to look at the table. And it takes me 357 miles. Now here comes a problem. When I look at the table for this data, at 5 hours, I'm 350 miles away. And at 6 hours, I'm 420 miles away. So I don't get exactly 357 miles. Okay? And I'm going to get real fancy and go 360. Well, 357 will work. Okay? So I'm going to have to, in this case, I have to actually solve it because I can't get a precise answer. I could, if the answer allowed me to, I could say between 5 and 6 hours or a little over 5 hours. But if we want to have a precise answer, we're going to say y equals 70x. Well, 357 is my y. And I'm going to solve. So 357 divided by 70 is 5.1. which is actually 5 hours and 6 minutes. I should not know this, but I do. So if I drive at a constant speed of 70 miles an hour, which, sad to say, I won't, because there's a billion little towns between Houston and Abilene, it would take me 5.1 hours, but it'll probably take closer to 6.5. It's going to be so boring. Okay.